Number 28 is a construction worker pulling a rope, pulling a plank up the side of a building with a rope. So as this thing is in motion, X and Y will those distances, those lengths will be changing, so they get variables. But the plank is always going to be 5 meters. So the worker's pulling the rope upwards, so dy dt is that rate of change. I don't know what's happening there. And that's increasing, oh, not 1.5, 0.15. Tough technical difficulties. So that's dy dt. I assume they're going to ask at what rate is the bottom of the plank moving inwards toward the building. How fast is the end of the plank sliding along the ground? So they want to know about this, and that's the rate of change of x. So what do they tell us? Anything else? That's about it. So we've got Pythagorean theorem when we're talking about the lengths of the sides of a right triangle. So I take the derivative with respect to time. Now I need to fill in the stuff that I need to know. It says when the 5 meter plank up beside a building, assume the opposite end of the plank follows the path perpendicular at a rate of 0.15 meters per second. How fast is the end of the plank sliding along the ground when it is 2.5 meters from the building? So it's saying when x is 2.5 meters from the building. So I know my x, 2.5 meters. Dx dt is what I'm looking for, the rate at which it's sliding along the floor. I don't know my y yet, but we can find it. I know my dy dt is 0.15, and that equals 0. How do I find my y? Well, I've got a right triangle now. I know that that's 5, and I know that that's 2.5. So I can do Pythagorean theorem. So that's y. So I've got 2.5 squared plus y squared equals 5 squared. 2.5 squared is 6.25 plus y squared equals 25. I subtract 6.25 from both sides. Get 18.75. I square root. I get approximately 4.33. So that's what's going in over here for my y. 4.33 goes in there. So 2 times 2.5 is 5 dx dt plus 2 times the 4.33. 2 times 4.33 times 0.15 is 1.3 approximately. Subtract 1.3. Divide by 5. And that's 0.26. That's a linear distance. So that should be, we're talking about meters in this problem. Yeah, so it's going to be meters per second because we're talking about a length. So it's not meters squared or anything. You can work through the units if you wanted to. So when we go through this, we've got meters here, we've got meters here per second, and we've got meters here. So this becomes meters squared per second over here. When I subtract it, that means this value over here is in meters squared per second, and this is in meters per second. I'm sorry, it's just meters. So when I divide meters squared per second by the meters, that's in the 5, this meter cancels with one of those, and we've got meters per second, a linear rate of change.